Problem 12. Side AB of ABC has length 10. The bisector of A meets BC at D, and CD is equal to 3. The set of all possible values of AC is an open interval m, n. What is the value of m plus n? So first, start us off the diagram, and now we're going to have to utilize one given piece of information, which is that the bisector of A meets BC at point D. They have to have given us this information for a reason. And the reason for this is because if we have an angle bisector, we can utilize this theorem that tan over y is x over 3, right? If you did not know this formula, then unfortunately this question would have been impossible to solve. But if you did know this, we can continue with the question. With this out the way, what can we say about the variables? When you have more than one variable, it's typically best to isolate one variable in terms of the other. So what can we say here is that let's try to isolate y in terms of x. The reason for this is because we're trying to find the range of x. So we want to solve this in terms of x. So how do we do that? Well, multiplying 3 on both sides gives 30 over y is equal to x. Therefore, y is equal to 30 over x. So that means this is 30 over x, not y. So let's get rid of that. And now we can proceed with the question. Because what do we know about side lengths of a triangle? A, B, and C, well, the sum of two sides is always larger than the third. Typically, when you're trying to find the interval for a side length, this is always what you're always going to be using. So now we just have to basically find all pairs of sums of two side lengths and solve for each inequality. What I mean by this is 10 plus x, for example, is larger than 30 over x plus 3. We also know x plus 30 over x plus 3 is larger than 10. We also know that 10 plus 30 over x plus 3 is larger than x. Now we have to solve for the interval of each x. To do this, let's first start with the first one, which I'll do in green. For the first one, what do we have? If we move everything to the left, we have 7 plus x minus 30 over x, right, is larger than 0. If we multiply x on both sides, 7x plus x squared minus 30 is larger than 0. So what can we say? Well, 30 is equal to 3 times 10, right? So that means we can say that this factors into x plus 3, or x minus 3, rather, x minus 3 times x plus 10 is larger than 0. So we have our first inequality solved. Let's now solve for the second inequality. For the second inequality, I'll do it in red. So for this one, move 10 to the left-hand side. We have x plus 30 over x minus 7 is larger than 0. What can we say when we multiply x on both sides? Well, x squared plus 30x minus plus 30, right? That's a constant. Plus 30 minus 7x will be larger than 0. Problem is, right, minus 7x and 30. Well, that's not compatible to be factored. So let's try to complete the square. X squared minus 7, or not x squared, x minus, right, 7 over 2, right, squared. Well, that's equal to x squared minus 7x plus 49 over 4. We got to subtract out the 49 over 4 and then add 30, which is just 120 over 4. And this simplifies into 71 over 4. So this becomes plus 71 over 4 is larger than 0. This would be our second solved inequality. What about for the third one? The third one, I'll do it in blue. If we subtract if we subtract x on both sides, we get 10, or 13 rather. 13 plus 30 over x minus x is larger than 0. So therefore, if we don't like this negative, right? So let's actually move everything back to the right hand side to get x minus 30 over x minus 13 is less than 0. If we multiply x squared minus 30 minus 13x is smaller than 0. So x squared minus 13x minus 30 is smaller than 0. Did I do something wrong? 13 plus 30 over x minus x, right? Right, so we have x, right, minus 30 minus 13 is less than 0. X squared minus 30 minus 13x. Yeah, that looks fine to me. So 3 and 10. Well, 3 and 10, that's not factor, or is it 3 and 10? 3 and 10. Or it could be 2 and 15. Oh yeah, it could be 2 and 15, right? So this could be x plus 2 times x minus 15 is less than 0. Alright, now we have the three inequalities solved for. So we just have to find the overlap, right? The overlap will be the answer because that's where all the answers agree with each other. Starting with the blue one is from, when is it less than 0? Well, it's an open face up parabola, so that's -2, and that's 15. So it's less than 0 when it is between -2 and +15. So this would be our first boundary. Now let's consider the red boundary. The red boundary is always larger than 0. So it's actually from 0 to infinity, because remember, the side length cannot be less than 0. So like that. And now what about the green one? Well, the green one goes from, well, it's an open interval, an open face parabola. So this would be -10. This would be +3. It's larger than 0 when it's larger than 3. So that means this is 3 and it's larger than 3. Where's the common region? The common region is between 3 and 15. So 3 and 15 will be our open interval. Therefore, what is 3 plus 15? Well, that's equal to 18. So your final answer would be answer choice C.